Hi, this is Tech again, and today, well, while the cascade is cooling down, I basically want to tell you what happened since last time you saw this A7N8X here. Uh, Basically, the board I showed in the previous videos got killed by me trying to figure out overvoltage protection mod. I still don't know how exactly, because the overvoltage protection mod for the CPU somehow killed the North Bridge without ever raising the voltage on the CPU. Anyways, I got around to mod another one of these boards. It's all ready now. I have a polamino S1XP in here, 2000 plus, with shorted L1 bridges, so I can run selectable multiplier. And the target here is to take down the overall polamino, and with that 180 nanometer Super Pi 1M record, and also probably Pi fast. CPU will be on cascade here, and well, I'm going to get back to you once I got something running. Okay, so it's a day later, and I am on cascade phase change once again. I swapped some stuff around, like the power supply here. This is a different one, but that doesn't really matter. What matters is that I finally fixed my FSB problems. For one, I had insulation on the CPU before that was, I don't know, resistive or capacitive, and basically messed with the bridges, and for some reason the CPU wouldn't boot high FSB with that. I fixed that, and I'm going to do a bit of a recap on the bench afterwards with all the mods on the board right now. My mods on the CPU, because I have unlocked multiplier on there in a wrong way, and I want to basically talk about the right way of doing it. Also, another really curious problem was my hard drive. As you can see, it's on a bunch of shipping boxes right now. That is because if I put it on this desk here, the cascade over here, this little monster, causes so much vibration that the hard drive drops out during boot sometimes. Anyways, 2.05 volts on the CPU, which is really low for polamino chips, but we managed our target, which was to set the overall Super Pi 1M record for, well, any 180 nanometer based chip basically. As you can see, 43 seconds, 391 milliseconds, running at 2.377 gigahertz here at FSB 226 with C2 memories, dual rank sticks, because my good single rank sticks are at the friend's place right now, so I can't bench single rank win bonds on here. Kind of limited by that. From my testing so far, the maximum my board does with these dual rank sticks in Super Pi 1M is about 238. And because of my improper multiplier mods, I can't run the X10 multiplier here. I can only run 9.5 or 10.5, and at 9.5 I can't do enough FSB, even though it would gain me a lot of efficiency to run over 230, but I can't get enough core clocks. I tried with the 9.5, and the best Super Pi 1M I got was around 44.6 seconds, I think. So quite a ways off from the record. Anyways, I finally got this, and I'm going to... I don't think I will be back here with a update, but I will show you later in the video what the final score of this session was, if there is going to be any better score than this one. Another note, I'm also not able to run VASA on here because, well, my hard drive is more or less half dead anyways. So if I run VASA, there is a good chance the system just crashes, regardless of clocks. So losing a bit of efficiency there, but I make it back with the high FSB. Okay, I thought this was too cool not to share again. I broke the 43 second barrier, and I also broke 42 750, which means I'm now more than 1 second faster than the previous world record for these polamino chips. Also, ridiculous clocks, I would say. Over 2.4 gigahertz, 230 FSB, and still under 2.1 volts. Also, I'm on Cascade, and all the previous records on these chips were on LN2. So, yeah, I think it has to do something with my capacitor mods, and I'm going to show you on the bench why I think so. Okay, here we are, directly after the session. As you can see, my CPU is still iced over. Let's actually remove this a bit. And remove the CPU. Now this board I'm definitely going to throw in the dryer afterwards. Or I think it's called a dehydrator. It's something usually used for food. It's ideal for drying boards. Anyways, that's the chip. With my eraser like spacer. This is on here, so it's the same height as the die, so you don't crack the die when you mount the Cascade. This is basically one use only, because there's always moisture under here that you're never going to get out. And a bunch of thermal paste on the top, which means, well, it's going to be really dirty if you reuse it. And let's remove this. I'm only removing this here because I want to show you the mod. It's, I would say, well-known mod in socket A enthusiast circles. It's basically just a hard unlock for the multiplier. Though I did it wrong because I didn't really research a lot. Anyways, there we are. Now let's see if we can get this to focus. Up here there's a bridge called L1, and I basically painted over it. Now, what AMD did back in the day was to configure stuff like multi VID of the chip and stuff like that, was to basically cut some bridges with a laser, and it leaves back a little trench in between there. And afterwards I found out that you're supposed to fill in this little trench with something like a epoxy or a super glue, because at the bottom of that little trench there is a ground plane. So you're grounding out, or there is a chance you're grounding out some of these individual bridges here, and some multis don't work. In this case, when I first modded the CPU, all the multis worked, but then suddenly the even multis stopped working, so only the ones with 0.5 work now. Which is why I couldn't run X10 and like 238 BC or FSB rather, and I had to run 10.5. In the end it was probably better to run 10.5 anyways, because this CPU did over 2.4, but I would have never expected that the CPU does over 2.4 in one. Anyways, that's about it for the CPU. Otherwise it's just a regular, actually let's wipe this off and maybe you can see the badge. It's a I don't think you will be able to see this, but I can still tell you, it's a 0218 DPEW badge. So from my experience from binning, actually, from binning these chips, the best batches tend to be somewhere around the early weeks of 2002. 2001 chips are usually garbage. Let's get in some more chips here. So, zoom out. All of these are basically my
my reject. Actually, I don't think this pile is reject, or is it? Yes, it is also. So that's the pile of reject polamino chips from my binning. I found some decent chips for the 2000, 2100 and 1800. The lower ones, I didn't really find good ones. There's also something about the stepping here. This is AG0IA. There is like two steppings that are good. I'm not sure which one was the other one exactly, but that's one of the good, and those are the late steppings. Anyways, let's move on to my little motherboard. There is a bunch of water here. Let's drain this. Again, this goes into the dehydrator afterwards anyways. But still, maybe not optimal. As I've shown in some videos before, we have a 12 volt mod here. This is an 8-pin input filtering choke, 3 pulleys for input filtering. Those are 330 microfarads. I know this is pretty low, but it seems to work. Then on this one I have, well, all my boards right now have salvaged aluminum polymers because I'm still waiting for my delivery from Mauser for the new stuff. So those are salvaged from one of the socket 940 boards. Those are 1500 microfarad 2.5 volts from Nippon Chemicon. Then on the back is where I think a lot of my huge frequency gains in benchmark, so under load, come from. Those are 7 SP caps. There is 2 times 470 microfarads, 2 times 330 and 3 times 220. Those are the 220 ones on here. All 2.5 volt rated, so I can't run super high voltage chips on this board, unfortunately. Those are 2.5 volt, those are 2.5 volt, and in the end I'm also planning to replace the MLCCs in the socket. Not sure if this is going to help anymore because, well, right now I can already not really measure ripple on here because, well, basically each pin I would solder, or I actually soldered, I think on here somewhere, measurement points for the oscilloscope is way too close to, it's basically closer to the massive amount of SP caps than it is to the core of the CPU. So I don't really get any good data from this, what arrives at the CPU, but the power on the back is really clean, and like V-droop and stuff like that is more or less non-existent. I have less than 10 millivolts V-droop on here. So again, I noticed this on the Pentium 4s as well. These overkill cap mods usually don't help as much for stuff like Valid, but they help more for actual benches. On the Pentium 4 I gained about 200 megahertz raw core clock from, at the same settings, from just caps. On this one I have no idea because I never tried this without cap mods. I just started off with it and basically, well, I know it's not really scientific, but sometimes I'm a bit lazy in this regard because in the end what I'm after is the best score and not always, at least, as you would say, basically electrical engineering data. Yeah, that's the board. Now this is not the board from the previous videos. Maybe if some of you have got the serial, this is a 2 week earlier 45, so a bit earlier board than the other one. And I also, of course, swapped memory caps just to be safe. Those are 6.3 volt though, so I can go up with the voltage. On memory I ran 3.2 volts on here. I had some problems with more voltage. I assume it is VTT related, so eventually I will do a VTT mod here. Those are just your regular Winbond BH5 based sticks. Those are 512 megs. I recently picked those up, so those are completely untested, but they seem to be at least decent. I would have preferred to run 256 meg sticks on here, but well, my 256 meg sticks are at a friend's place, so I can't really run them. At least the good ones are. I found a mismatched kit of Corsairs that I have around here. I'm going to do a quick and dirty test on them and maybe try to run them. Because Socket A doesn't really like the dual rank stuff that much, especially for high FSB. So basically what's next for this board is a VTT mod and hopefully this time a overvoltage protection mod without killing the board. Last one I killed, but there I did it wrong, and then on the on the previous board I killed the North Bridge. So basically I used that board with the dead North Bridge to figure out the overvoltage protection mod, and I got it working there. So I'm going to basically take the experience from there and transfer it to this board here. Though I'm pretty sure I don't need over voltage protection mods anyways, because even at like 2.08 volts these chips seem to be running pretty happy. And well, I already got the record on this one. I will do the like hardware records on the 1800, 2100 and stuff, but I'm definitely not gonna post a video about that because, well, at least for me the big target was having the fastest 180 nanometer based CPU overall, as in SuperPi. In like valid and raw frequency, the Pentium 4 is going to be better, and well, I will probably attempt something on the Pentium 4 someday. I have a really good socket 423 Pentium 4, and I have like a tray or two of 478 Pentium 4s, but like the Willamette chips on 478 are not really fun. Anyways, I think I will cut to a quick overview of the scores I actually achieved here or something. So yeah, that's that.
Okay, so I submitted everything, and well, I would say the one I'm most proud of is the SuperPi score, definitely. Mostly because this is, well, fastest SuperPi 1M on a 180 nanometer CPU. There is the little chip. Because back in the day AMD was king for IPC, so this core definitely has a way better IPC than a Pentium 4. Pentium 4s are around low 50 seconds, the best ones. This is low 40s, so quite a bit faster. Now, the previous top score was from Tabaka on a XP 1700 Plus, also LN2 cooled. Basically, he didn't unlock his chips and he ran at the stock multiplier of 11. So, that's the reason why the 1700 plus score is so much higher, because 1700 plus has a stock multiplier of 11, and with these chips basically what you want is bandwidth and even more bandwidth. So high memory clock, dual channel at 2225, or in my case 11. So that's the reason for that. Another score I'm somewhat proud of is 2.5 gigahertz valid. Now again, valid doesn't say anything about anything, but it's the first over 2.5 gigahertz valid on the polamino cores. So I beat a bunch of LN2 scores with that. As you can see, this one is LN2, this guy is single stage, which is crazy. I wish I had his chip, honestly. Also, all of them are LN2. So yeah. Then I just took some hardware first places, nothing impressive here, just ran PiFast as well, 2.4 gigahertz. FE is complete garbage. I didn't optimize for PiFast here, so yeah. I also didn't optimize for W prime. This is just doesn't even have the W prime tweaker, which set it to a real time. This is just one click and run, just a hardware record. So nothing special there, I would say. Yeah. Another huge shout out I think I really have to include in this video is to the BIOS modder known by the name of digitalbath. I'm going to leave a link to this here server with the modded BIOSes for the Asus board in the description. I'm running this one here, I think. No, actually this one. A7N8X-E 619 XT B2A. Now this one here is basically a BIOS where you can select the ROM zips in BIOS, and this has a bunch of other fancy things in there that I'm still not 100% understanding. But this one is definitely a great BIOS so far. So I'm going to leave a link to this here in the description so you can flash them on your Asus boards. They really need the custom BIOSes to be good. Before I think I ran this one here, no, not sure. Anyways, I think that's about it for the Socket A update. Now, I hope you could learn something from my ramblings about my overclocking. And yeah, bye.